Hello everyone, welcome to Equal To, and in this video we will be coming up with a summary of matter in our surroundings. So we have completed every single topic in this chapter. We have also discussed all the questions in this chapter. Now this is a video where we are going to summarize everything that we have learned in this chapter. This you might consider it as a last minute revision. Please don't watch only this video and ignore the rest of the things, because we have explained everything in detail in those videos. This is just a collection, this is just a gist of all those things. You can use this to revise everything maybe just before the exam. That is what it can be used for. This is not a supplement, this is not a replacement for all those videos. There we have gone through a lot more of these topics in depth. This is just a surface level revision. So with that said, we'll get into this video. So we'll be revising matter in our surroundings. So we start with what is matter. So we have already learned matter is something that occupies space and has mass. And since we have two new things here, volume and mass, we are just going to tabulate their SI units. So the SI unit of volume is meter cubed and the SI unit of mass is kilogram. So then comes the classification of matter. Matter can be generally classified into based on its physical properties and chemical properties. So in this chapter we will be focusing only on the physical properties of matter, and that comes to the state at which that is presented. We'll see more about this. So matter is generally made up of very small particles and they have space in between these particles. Now diffusion. Particles of one type, when they get into the spaces of particles of other type, generally we call this diffusion. An example could be dissolving a spoon of sugar in water. So the sugar particles, they get in between the particles of water, and hence this can be an example for diffusion. Characteristics of particles of matter. So particles of matter have spaces in between them. We just saw that now. And the second characteristic is that particles of matter are continuously moving. And then as the temperature rises, particles move faster. And particles of matter have a force attracting between them. There is a force acting in between the particles of matter, and the strength of this force varies depending on the type of matter or the substance that we are actually considering. Now basically when it comes to state of matter, there are three states: solid, liquid and gas. And the variation in characteristics, there is a variation in characteristics based on the state of matter. Comes to solid state, some examples could be a wood block, a book, a needle, a pen, etc. And the properties are they have definite shape, they have definite boundaries, they have fixed volumes, and they have negligible compressibility. Now moving to liquid state, they take the shape of the container, so they don't have a shape, they have fixed volume and they have high diffusion. So liquids can easily diffuse into liquids, and also solids can diffuse into liquids, and in some cases gas as well diffuses in liquids. Now liquids can also be called as fluids, and the reason being they can flow and they can change their shape. Because of these two things we call liquids as fluids as well. Now to gaseous state, gases are highly compressible when compared to solids and liquids, and also gas diffuse very fast into other gases. When a gas is released into air, it diffuses very fast. Air is also a gas. So gases can diffuse very fast into other gases. Now coming to density, density is mass per unit volume of a substance, and the formula for density is mass divided by volume. Now this is a table that is very important. It has been asked many times and it's a very important question, and you can get a lot from this single table itself. So difference in characteristics of states of matter. Now when it comes to shape, solids have fixed shape, liquids take the shape of the container, and also gases, they don't have shape. Volume, solids have fixed volume, liquids also have fixed volume, but gases, they don't have fixed volume. When it comes to rigidity and fluidity, solids are rigid, liquids are fluid, and also gases are fluid. Intermolecular force of attraction, this is the force acting in between the particles of matter. It's very high or maximum in solids, it's less than solids in liquids, and it's very low in gases. The next thing is intermolecular space. This intermolecular space, it's very less in solids, it's higher in liquids, and it's maximum in gases. And the last thing is compressibility. which is negligible in solids. Liquids are generally compressible and gases are highly compressible. Moving on, we have kinetic energy. Kinetic energy is the energy possessed by the particles of matter that makes them move. The particles of matter, as we know, are generally always in motion. They never take rest. They never are in rest. So, they possess some energy, that is what we call as kinetic energy. Molecules of gas generally vibrate randomly as they have maximum kinetic energy. Melting point. Melting point is the temperature at which solid melts to become a liquid at atmospheric pressure. That is what we call melting point. So, we also seen something called fusion that will come in the later slides, but generally speaking, when solid melts at a temperature at atmospheric pressure, that point is what we call as melting point. And it generally indicates the strength of force of attraction between the particles of matter. Higher the melting point means the force of attraction is very high. The next definition is fusion. Fusion is generally what we call as melting. So if a solid melts into liquid, it is also known as fusion. And the melting point of ice is 273.15 Kelvin. This is an important number, you have to remember this. So what exactly is Kelvin? Kelvin is another unit to measure temperature. Generally in our day-to-day life we use Celsius, and Kelvin is a similar quantity. So 273.15 Kelvin, which we know is the melting point of ice, is considered as 0 degrees Celsius. Okay, for convenience we consider 0 degrees Celsius as 273 Kelvin and we just round off the 15. Okay, so conversion between Kelvin scale to Celsius scale. Kelvin scale to Celsius scale you have to minus 273, and for Celsius scale to Kelvin scale we have 273. We also worked a lot of problems in this particular topic, that is converting from Kelvin to Celsius. We have all those videos in our playlist, so please check them out. This is just a revision. The next thing is latent heat. Latent, as we know, meaning hidden. Okay, so the heat that is used to overcome the force of attraction in between the particles of matter, which doesn't increase the temperature of the matter itself, is what we call latent heat. The next thing is latent heat of fusion. Latent heat of fusion is the amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point. That is what we call as latent heat of fusion. So this is just a combination of latent heat and fusion. So the amount of energy required to melt 1 kilogram of solid into liquid at atmospheric pressure at its melting point. The next comes boiling point. Boiling point is the temperature at which liquid starts boiling at atmospheric pressure. And boiling is generally a bulk phenomenon. A lot of these molecules gain energy simultaneously and they evaporate. So it's a bulk phenomenon. And for water, the boiling point is 373 Kelvin, which is also called as 100 degrees Celsius. The conversion goes through. The next comes latent heat of vaporisation. It's the amount of energy required to change 1 kilogram of liquid into gas at atmospheric pressure at its boiling point. So this is one thing that is very important. We are mentioning at its boiling point. If it's not mentioned, it is not even boiling. It's just evaporating. That is a concept that we'll see later. You will understand this very well if you have already gone through all our videos. So the amount of heat energy required to convert 1 kg of liquid into gas at atmospheric pressure at its boiling point is called latent heat of vaporization. Next comes sublimation and deposition. Generally, when solids are melted, they become liquid. But if a solid on heating, if it directly becomes gas, it's what we call sublimation. And gas on cooling, if it directly becomes solid, that is what we call as deposition. ATM, atmospheric pressure. It's the pressure that the atmosphere has at sea level. So what exactly does it mean? The air mixture, when the amount of pressure it exerts on the environment, that is what we call as atmospheric pressure. And it's 1.01 into 10 power 5 Pascal. Pascal is the SI unit of pressure, but atmosphere is also a unit of pressure that we generally use. Next comes solid carbon dioxide. So it is also called as dry ice. It is stored under high pressure, and on keeping it at atmospheric pressure, it instantly converts into gaseous carbon dioxide. So it's an example for sublimation. So there is a conclusion that pressure and temperature both can determine the state of the substance. You can convert from one state to another by applying pressure or temperature or by applying both. Evaporation. Evaporation is the phenomenon that changes liquid into vapors at any temperature below its boiling point. If it's converted at its boiling point, it's called boiling. But if it's converted below its boiling point, it is what we call as evaporation. Factors that affect evaporation are surface area, temperature, humidity and wind speed. As surface area increases, rate of evaporation increases. As temperature increases, rate of evaporation increases. As humidity increases, rate of evaporation decreases. And as wind speed increases, rate of evaporation increases. So how does evaporation cause cooling? Evaporation, when on happening evaporation, it absorbs heat from the surroundings and converts into vapor. So since heat is absorbed from the surroundings, it causes a cooling effect. Now these are some measurable quantities of the quantities that we have, these are the units of the quantities that we have seen so far. So for temperature, the SI unit is Kelvin and the symbol is K. For length, it's meter M. For mass, it's kilogram kg. For weight, it's Newton N. For volume, it's cubic meter, meter cube. For density, it's kilogram per cubic meter, so kg m power minus 3, and for pressure it's Pascal. So that is the entirety of this chapter. We have completed this chapter. Now this video is just to revise things. If you haven't watched the previous videos, you'll learn a lot more watching those videos. This is just a revision. I hope this was helpful. Maybe you could use this right before the exam. Thank you so much for watching. If you have further any suggestions, please put them in the comments and I'll get back to you. If you haven't subscribed to Equal To, please do that. Thank you so much for watching. See you in the next video. Bye for now.